Hi, in this video I'm going to show you how to use RStudio to execute and complete a basic homework assignment. First of all, let's start on the front page of our course Moodle, and on this page you will notice a link right down here to RStudio web server, and if you click on that you should get a tab opening that you can log into using your university ID and password. Mine seems to have just opened up directly, and you'll notice on RStudio you have what is called the console, and the console is for executing commands and doing short computations like 2 plus 3, and it'll add those together and give you 5. You can do basic calculator computations. In the lower right corner there's some tabs for work files that you're going to bring to the server, and those will go down here. If you make any plots, you'll see them in this pane, and during the video today we'll talk some more about the different panels of RStudio. I will be giving you an account, and if you're not able to log in, it means I haven't opened your account yet, so you need to see me about getting that done. Let's go back and actually execute a practice homework assignment so you can see how things work. If you go under the Getting Started tab, you will notice that there is a folder called Practice Homework Files, and there really aren't too many files in here. I think there's just one. Why don't we click on it? And you can see that there is a file in this folder called rmdpracticehomework.rmd. This is an R Markdown file, which is the form of your homework. So what we need to do is get this file from Moodle into your local computer, and then from there let's upload it into RStudio. So we need to do some file moving from Moodle to your local computer or device and then to RStudio. So let's do that and click on this file, and it says what do we want to do with it? Open it, save it, whatever. And I know your instinct is probably to open this file and look at it like, oh my gosh, what's in here? I want to see. Don't do that. You can do that in a moment. Instead what you should do is choose to save this file and click OK, and it will go into your downloads folder, and that will be true I believe on a Mac or like on a PC Windows computer like this one. It went into my downloads folder, and if I want to just verify that it's there, you can just sort of look and you can see, aha, RMD Practice Homework is sitting in my downloads, and that's where I want it. Then what you need to do is change your tab to RStudio and go into the Files tab, lower right on RStudio, and click Upload. And choose the file you want to upload. Well, you want to upload that homework, so click on Browse and navigate to the Downloads folder, and there you will see the practice homework file sitting there. Click on Select, open it, and click OK, and you'll notice it just went up into our workspace on the server. And you can click once on that file and it will open over here on the left. And you can see that there's a bunch of code and typing and things in here. It's called a practice homework document. And everything in white is just text, like on a word processor, but you'll notice there's code blocks, gray shaded areas, and these are going to be executed by the statistical software R, and the results will be intermerged back into your word processing document. And this is going to be the nature of how we do work in this class. The gray areas are going to be executed by the statistical software, and they're going to be intermingled with the white text areas that are not highlighted in gray. So let's get started with what's going on in this file and explain it a little bit. The title is up here in line 2, Practice Homework Document. And the next lines 8 to 13, load some packages. And these are supplemental pieces of code that R needs to execute this particular homework. We need to add on some additional code from the knitter package, KNITR, OpenIntro, and ggplot2. And when you start in this course, these packages are not loaded. You're going to have to do something to make these instructions from these folders available to you. And we're going to do that right now over here in the Packages tab. Let me say that once you do this, you will not ever have to load, you're going to need to load packages, but you're never going to need to install packages again. Once you install the OpenIntro package here now today, you won't have to do it again. So let's get these things installed. Packages, and let's choose to install, and let's type in what we want. We want knitter space OpenIntro space ggplot2, and it knows these are packages we would do. Click on install, and you'll see a bunch of execution happening down here in the console tab, and that's just reassuring us that this extra code is being installed, and this might take several minutes to run. While it's running, you can see that there is a red stop sign, and that would be what you'd click if you really wanted to stop this process. But right now it's executing, and we can see that it's executing and doing something because the red stop sign appears available to us. And we'll just let this continue until it finishes. It might take 5 minutes. Okay, the installation is finished, and right now we can go back to our files area, and we'll see we have the practice homework that we're working on. And let's take a look through the file a little bit. Lines 17 to 31 are computing some summary statistics, which you're going to learn about in the class. If you look in on this code carefully, you'll see there's mean and median, quantiles. You'll learn in the class about what these things are. I'm not expecting that you are going to be able to know and understand code like this, but you are going to understand some other code in the future. So right now, on line 35, you should wipe out your first name and your last name and actually type it in there. So I'm going to put in my first name, John. My last name happens to be Anderson, and that will change the name that appears in my document. My first problem uses some data from out on the internet to understand how university professors are being paid. And line 49 in this code goes out on the internet to an account that I own, and there's a data file sitting there. The .csv right here means it's a comma-separated values data file. And this data file is going to get read into an R software object called AAUP-DAT. And that's what this particular line 49 is going to do when it is executed. When we go down below to line 54, there are going to be summary statistics printed for every variable in this data set. In line 63, I'm going to make a histogram of assistant professor salaries, and it's going to make a picture for me. And then there are going to be various things that are done throughout this file. Remember, everything in gray is some kind of R analysis, like a computation of numbers or a graphical display. There's going to be a couple graphical displays that's produced from lines 89 down to lines 95. In the first part of this course, I'm encouraging you, advising you to never bother typing anything in any of the gray areas. Please stay the heck out of the gray areas until you're experienced and you know what to type in the gray areas. You are able to type in white areas, and that's just going to be typing your answers and what you think is going on in the document. What I would advise you to do when you first start working on a homework like this is every little gray chunk can be executed separately by going over to the right of the gray chunk and clicking on the Run icon, and this will load all of the packages that are being asked to be loaded in lines 8, 9, 10 to 12. And that was done. There's no output produced from it, but things executed. You could see it probably down here in the console that the packages knitr and openintro and ggplot have been loaded into my session. Installing them just makes them available. Here it puts them into use. And then I'm going to execute this code right here about summary stats, so it's available to me. Click Run, and this definition has been created. You'll notice up here in the upper right corner a function for analyzing summary statistics called SumStats has been created, and that is this object right here in line 18. Now I'm going to go down and execute the loading data command in this block, line 44 to 50. Click on Run this code, and the data has been created. It's right over here. It's got 1,161 observations, so a lot of data and 17 variables. If you wanted to see what it looked like, you could click on it, and you'll notice that every school in the United States name is right here. You can see what state it's in. You can see what type of school it is. You can see the salaries. By the way, these salaries are in hundreds of dollars. And then there's a lot of other variables. And you can scroll down if you wanted to start seeing where UMM is and so forth. There's a lot of schools in here. 1,161 of them, to be exact. You can close that and get it out of your way. You can always open it again. Let's summarize the data, get summary statistics from line 54. We'll run this chunk, and you'll see printed output appears on your screen. Every variable has been given a summary. Numeric variables have things like mean and medians computed. Things that are category data, like what kind of school it is, just gives us frequency counts. The next part of the document makes a graph. So let's go ahead and click on that. And the graph should be completed. And you get to see a little bit of histogram for assistant professor salaries. And what you can see from this is a lot of salaries are between the, this is a little bit of old data. Professors get paid more than this now, but this is sort of showing you that professors in the days of when this data was created were getting paid between $30,000 and $40,000. There's a big peak of observations in here. It looks like there's a little bit of right skewness, and so when it says provide a histogram and describe the shape, what I would do is I would just click right here on line 67, and it says put the answer here, and so I'd say this distribution has slight right skew. You'll learn about right skewness in the class. What I'm showing you right now is how to put in answers. And you can sort of execute every little step of code in this document so that you can see what there is to see. Here we've computed some summary statistics, and in line 82 it says what should we put for a typical value. Well, you don't know this yet, but the thing you should report for these data would be the median. And so I would say typical value is median salary and that would be, if I look at the output right here, it says 349. Remember, those are in hundreds of dollars, so that would be $34,900. And then I could type in the value that I should use for the spread, and you'll learn about these things in the class. And that's how you would give answers. Let's execute one more set of plots, box plots in this case, and you can see what they look like. Here is one set of box plots that I could look at. There was another set produced in line 90, and if I wanted to see those, I could click there. They're essentially the same, just produced with different styles, but I wanted you to see how to click and toggle between different displays. When you have finished giving answers and putting answers in this file, you need to create a final version that you will submit for your homework. And to do that, go up here to this knit button and choose, click on it, and choose what kind of document you want to produce. I think I prefer that you will produce PDF documents. So please click on Knit to PDF, and then it looks like it is executing. When I look down here, all of the computations and all of the writing that I've done are getting put together, and the final result pops up on the screen as a PDF viewer. You notice my name is John Anderson, and you'll notice the graph has been produced. My answer about the shape is right down here on the bottom of page 2. Here are some summary statistics, and I've given the typical value right here. And if you scroll through the document, you'll see there's several other graphs and other computations, and this is the kind of thing that you will produce for your homework. If you look down here on the bottom of this file in problem 3, you will notice that there are some mathematical symbols in Greek letters, like mu equals 36.7 degrees, and sigma is 0.7 degrees. And how did I get those to be in the document? Well, let's go take a look at my code down on problem 3, and you will notice something, I hope. Up here where I wanted to talk about mu and sigma, you will notice I have the special instructions to make those codes within matching opening and closing dollar signs. Opening and closing dollar signs tell our software to format it as a math symbol. You notice right now when I hover my mouse over it, it reformats to what it will be produced. If I do that over the sigma, I should get the same thing, and you can see what those things do to be produced. I have some more math symbols down below here, and if you hover over them, you'll notice that I have formatted with math. I'm not going to expect that you will be wanting to do that necessarily, but I want you to know it's available. Other math symbols with subscripts and superscripts are given down here in this very last line, 149. There is another interesting thing going on in problem 3. In this code block that starts at line 141, I have computed something. It involves the normal distribution, which you'll learn about probably in a few weeks. But I've computed a number called, put in a variable called my answer. And if I execute this code, you'll see that my answer is like 37.28, and if I show you the formatted page, you will notice it's 37.28. But the other thing to notice is that in the middle of all of this text, I've written out the value 37.289. However, I didn't type that number, you'll notice that would appear right here. And I didn't type the number, I typed the variable that contains the number. And this code with backtick R, variable name, end backtick, puts the number in the document without me having to type it. And that saves a lot of work creating reproducible documents. So I wanted you to know about that. And now let's learn how to turn this in. Here is the PDF document that you just created that we would be looking at here. You can either download this document to your computer from this window, or you can download it from over here in this Files pane. So let's click on the PDF right over here in this checkbox, go to the blue More wheel, and Export. And that will download this file to your computer. And let's do download. And don't open it, otherwise you'll just be looking at it again. You want to get it on your computer so that you can turn it in on Moodle. So do Save File, and that will go into your Downloads folder. You can click, you can see it's there. Now let's learn how to turn this thing in. We'll go back to Moodle and go to the Getting Started tab, and notice that there is a Practice Homework submission link, and click on that, and okay, let's try that again. Let's go to Getting Started, and again going to Practice Homework Submission, click on that, and then you should see a button, a blue button called Add Submission. This is where you're going to turn in your document. So click on that, and it says that it will accept PDF and HTML documents. If you put in something other than that, you'll get an error message. I'm going to go up to my downloads right here and drag my PDF into that box, save changes, and that homework has been submitted. My file's been submitted. If I ever wanted to update it and change a mistake or fix something that I find out wasn't right, I could edit the submission, and I could click on that document and delete it, and it could go away, and then I could add a new one, a new version, if I wanted to. And you save changes, and you can go back to your homework and go back to Moodle, and that's how you turn in a homework document. Let me know if you have questions. I'm happy to help you.